I wonder how many fragments are in those test tubes.
Is there any way of separating the fragments?
Yes, there is. It's called gel electrophoresis.
The technique of gel electrophoresis is used to separate DNA fragments which have been produced using restriction enzymes. The solution containing the DNA fragments is loaded into the wells of the electrophoresis apparatus. An electric current is run through the gel and is used to establish an electrical field around the fragments. Over a period of time, the fragments of DNA will migrate through the gel towards the electrode of opposite charge.
This is an agarose gel. You can see that there are wells at the top end. The solution is put into those wells and an electric current is applied. Now, the current provides an electrical field around the fragments of DNA. And over a period of time of about an hour, the fragments migrate towards the electrode of the opposite charge.
And since the fragments are different sizes, they'll migrate different distances, right?
Right. Now, which one do you think will migrate further? The larger fragments or the smaller fragments?
I would say the smaller fragments would go further, because they can pass the gel molecules more easily. The larger ones might be blocked somehow.
Okay. Now, those enzymes have had enough time to digest the DNA. So what we have to do now is add 2 microliters of this dye to each of those test tubes. This will make it easier to follow the fragments in the gel. So let's add the dye now. Now we're ready to load the wells. We'll put this solution here in the first well.
What is it?
This is a marker. It's made up of fragments of DNA of known lengths. Now, what would be the benefit of that?
It would be used as a standard. We'd have something to compare our results to.
Good. Okay, let's load the first well. All right, now what I want you to do is continue loading the other wells in the same order as those test tubes. That's well done. Now, all we have to do is apply the current. So we'll cover the apparatus, turn on the power, and wait for an hour.
Okay.
The process of gel electrophoresis is being used to isolate genes in pigs. Those genes responsible for the production of lean meat and the prevention of disease, specifically pneumonia, are of special interest to breeders.
Let's assume that the wells of the gel are up here. Can you use these fragments to demonstrate what's happening inside this apparatus?
Sure. Inside the tubes were different fragments of different sizes. Electrophoresis separated the fragments according to their size.
The smallest fragments moved furthest away from the wells, so they separated like this.
Good. Now, let's take a look at the results.
What's the relationship between the gel and the UV light?
Well, when the ethidium bromide is inserted into the DNA and you expose it to ultraviolet light, what happens is that it absorbs the ultraviolet light and then emits a fluorescence. And we can see that on the computer screen. And there we go. You can see right here, that's our marker lane, and there's several fragments there. This is the EcoR1 digest, and there's multiple fragments there as well. The HIN3 digest, again, multiple fragments. There's even more fragments in the double digest lane. Lastly, the uncut DNA shows only one DNA molecule and no other fragments.